Hello and welcome to another video. In this video, we're going to be working on binary tree post-order traversal. And in this one, given the root of a binary tree, return the post-order traversal of its node's values. So a post-order traversal means you go left whenever possible, then you go right whenever possible, and then you take the root value. So essentially here, we can't go left, but we can go right. Then we can go left. So left takes priority, so we'll go left here. Then we can't go anywhere else, so we recurse here. We already went left, we can't go right, so this is the next value, and then this is the last value, so it'll be 3, 2, 1. An empty array is empty. And so the main traversals, let's just cover them really quick. Honestly, I don't think you're asked too often, like, give me an exact traversal, but you want to know, like, when I do these traversals, kind of what's my result. So there's a pre-order traversal, which is left, or actually it's root takes priority, then left, then right. There's an in-order traversal, which is left, root, right, and post, which is left, right, root. So this is the thing takes priority. There's also one more that I guess don't have a name, but doesn't have a name, which is used sometimes in problems, which is right, left, root. And you actually do, like I do use this sometimes, like if you want to get like the right side view of a tree or something, you actually want to go this way. But the main idea is pre-order traversal basically visits the root first, in order. So here's a binary search tree where every value on the left is smaller than its parent and every value on the right is bigger than its parent. So an in-order traversal, if we actually look, this is the reason it's called in-order, is if you do an in-order of a binary tree, basically what's going to happen is you're going to go left prioritize, so you'll go here, then here, then here, then here, then here, then here, and here. And so this would be the ordering of an in-order traversal here. So the nodes would be visited in like 1, 2, 3, 4, 5, 6, 7, 8, the way I have it here. But let's take a look at what the post-order traversal of this tree looks like. So essentially, let's just write it out in like maybe an array or something. Might need a couple more, but okay. So post-order is the idea is we're going to visit the root last. So we go left, we prioritize left. So we go here, here, here. We can't go left anymore. So this is the node we're going to cover. Then we're going to go back, and now we prioritize right. We can go right. So we're going to take this node. Then we go back here and we take this. So 1, 3, 2. Then we come back here, we prioritize right. And then we prioritize left because we can go left. So 5. And then 7, because we're going to come back here, we prioritize right over the root. And the idea is when I say the root is like we're at some node, so it's the root of the new subtree. So when we're here, this is like the new subtree, and then the root is covered last. So it's going to be 5, 7, 6. And then we're going to go back up here, 4, go back up here, we prioritize right, and then we go left. So we're going to have the same thing, same kind of pattern, 9, 11, 10. So I guess we need a couple more. So let's add a little bit more here. Okay. There we go. And then, so we've covered all of these. Now we go back here. So this whole thing is still uncovered. So remember we prioritize right, so we can go right. Now we prioritize left. So left is like first priority, right second priority. So we go 13, recurse up here, prioritize right, so 15, then 14, then back up here, and then the root's last. So it looks like that. And you can do this in two ways. One is recursion and one is a stack. So recursion is by far the easiest, and that's what I'd recommend. And basically in recursion, you have 3 lines of code whenever you're at a node. And you just change these depending on which one you're in. And the lines of code are traverse left, write down node value, right, into the array, and traverse right. And this recursive function will basically do all of these. So if in pre-order, we want the root value first, that's just the value we're at. So for pre-order, we'd want to say, okay, whatever we're at, let's write down the value, then let's go left, right. So write down the value just basically means root. Then in order is left, root, right. So we would just move this line up here. So it's literally 3 lines of code that you can rearrange. This would be in order. So traverse left, write down node value, traverse right. And for post order, we want to go left, right, then write down the node's value. So this is basically going to be what we're going to look at, and then I'll show you quickly a stack way to do it. I would recommend, honestly, not ever doing the stack. It's more just like if you want to learn how you can. but I think it's more complicated than it needs to be. Okay, but because it's an easy problem, there's some time. So, okay, so for the recursive function, a bunch of ways to do it. Essentially what I'll do is I will just make an array and pass it into my recursive function to write in the output. So I'll just say like return, and then I'll make a traversal function, which will give the root and will give our post order traversal array. So we can call this like array list integer, call this post order. And then yeah, for pre-order and in order, you just have to swap a few lines around in this traversal function like I showed in the picture. So basically 3 lines of code. So it goes a private list integer traverse, and we'll take a node, current or something, and then we'll take the post order traversal. Okay, and we also have to check for null nodes. So you can do this one of 2 ways. You can, when you do these traversals, you can either make sure they're not null, or you can just handle the null case. So we'll just handle the null case. So we'll say if cur is null, just return post order. Okay, so now basically for post order, we have to traverse left, then traverse right, then write down the value. So we can just do that. So traverse left. And we don't have to worry about if it's null because we're handling that. And we'll just keep passing this array everywhere. Traverse right. And write down the value, which is just post order add current value. And that's it. Then we just return this. So like I said, for in order and the other one, you would just swap these 3 lines around in the order you want. I think that's it. Let's see if we have any errors. We do. I'll probably need this. Okay, let's see the error. Okay, not enough. Oh, it's because we need this, I guess. Oh, actually, no, we need this, right? New array. Actually, we don't need to give it a name as well. Okay, there we go. Okay, so that's the recursive solution. Let's quickly talk about the stack solution. Let's make this tree smaller. No need to have something so big. So the idea of the stack is we're gonna kind of do this backwards. You can't, like, it's very hard to get it in this exact order. So we're gonna actually traverse backwards. So in our post order, the priority is left, right, root. So we're gonna reverse the priority, and then we'll just have something that we need to reverse at the end. So, or you could use a deck, right? Either one. I guess, yeah, let's just use a deck for the post order. So we're basically gonna always write at the front, which will basically give us like a reverse thing. So instead of going left, right, root, we'll go root, right, left. And I'll kind of show you how that's gonna work. So let's move these up and let's draw a stack and get rid of this. Move these over here. And then we can code up the stack solution. Okay, so there's actually a nice stack picture as well here. Okay, so basically what we're gonna do is this is like our stack, and then we'll have our post order result. So that's gonna be the array, and we're always going to be, I guess it'll be more like a deck, so we'll just always be writing to the front. So I'll start writing over here, but we're always gonna essentially be writing to the front. Okay, so we're gonna put this, like we're gonna start at the root, and we're just gonna say, okay, let's put the root on the stack. And what we're gonna do is we're gonna pop from our stack, and then we're gonna wanna put nodes in a way that the node that should get accessed last gets accessed first. So remember I said here we want to do left, right, root is like our normal traversal, but here we kind of want to do the opposite. We want to do root, right, left. Which means because we're popping off the stack, we're gonna write down the left value first, so like left, and then the right. And because we're popping off the stack, we're gonna visit the right first. So, and I'll kind of show you how that goes. And then for these other ones, you can basically kind of do the same thing. You just take the reverse of this thing. So we're gonna start here. We're gonna say, okay, let's just pop off the stack. Let's put it in our post order result, always at the front. So imagine this is the front of the answer. This is gonna be a queue. Or like I said, you can make I guess actually let's just do it this way. Let's just keep appending to the back, and we'll just do like a reverse at the end, which will also work. So this will basically give us the reverse order. Then we put on the left child, which is 4. Then we put on the right child, which is 12. So it's always pop, put on left, put on right. And then this will give you the pattern. And if you're not sure, like just try to do some random stack stuff. The key though is you always want to like visit a node, pop it right away, and put on the children. Because if you keep it, then like how do you know if you visited the children already? It's going to get more complicated. Okay, so essentially we're going to put on these. So we're going to pop off the 12, write it in, and put in its children, left and then right. So 10, 14. And then we're going to pop off the 14. This doesn't have any children. So pop off the 10. Doesn't have any children as well. Then pop off 4. This does have children, so we put on 2 and 6. And then we pop off 6, and then we pop off 2. And this should be the right order, but backwards. So let's actually do a normal post order and see what we get. So remember, we prioritize left, so this is going to be 2. Then we prioritize right, so 6. Then the root, so 4. Then we come back here, prioritize left, so 10. Then the right, so 14. Then the root, 12. And finally this. So you can see we got the right order. This is basically just in reverse. So then we just take this and we reverse it. So let's just do that. So we'll have a stack, and then we'll have a post order array that we can reverse at the end. That should work as well. So let's get rid of this helper function. And yeah, like I said, I'm just showing the stack for like, so you can see how it's done, but I would basically almost never use it. I think Recursive is a lot more common, and I would never do like the Morse traversal or any other kind of stuff, because like learning one function for something specific is just kind of silly in my opinion. So I would 99% of the time use recursion, just be able to visualize it, be able to see like if I move things, what happens. Okay, so we'll have, I guess we'll have an array result or something, or we can't have an array, we have to have an array list result, right? Yeah. Or we can have a queue. I guess we'll just have an array list and then we'll reverse it. It's fine too. Okay, because we're returning an array list, yeah. So this will be post order. Okay, and then we'll have a stack. Yeah. So for a stack, I'll just use a normal array list as well, I guess. Call it a stack. I think people don't really use stack in Java, so. Or actually, let's use a deck instead. So yeah, so array deck. Call this a stack. I think this is better. Okay. So we're gonna start off by putting the root on the stack. So we're gonna say, don't know the exact thing here, so let's see. This is gonna be stack, and then some kind of push, add, and then root. And we basically say like while this stack has length, let's keep doing stuff. So while stack dot size, or I think is empty. While it's not empty, let's keep doing stuff. Add tree node. Oh, right. So this is not an integer. This is a tree node stack because we actually need the tree. Okay, there we go. So we're gonna say like we're gonna pop off something. So we'll say like tree node per stack, and then we need pull last, pops off the last one. And so we need to add this to the post order traversal. So we'll say post order add current value. And if the current has a left, then we'll add it to the stack. And same thing for the right. So this needs to be just not equal null. Okay, let's actually do this instead. I don't know why I didn't do that earlier. Okay, so essentially that's that. And then all we have to do is reverse it. Okay, so we'll have our list, and then I had to look this up actually. So we want to do a collections.reverse, and that can do it. Or you can just make a new one if you didn't know about that one. Post order and return it. Okay. And let's see the problems we have here. Null pointer. Oh. one time. Oh, right. So if there is a root, I guess. If root does not equal null, I guess you can have an empty tree here. So there you go. Okay, hopefully that's it. Yep. Okay. So either one's fine. I just showed this one because it's more complicated and the recursive one's a lot easier. So this is going to be linear and linear. And hopefully this is helpful. The main takeaway is, like I said, know the traversals. I honestly wouldn't even care about like knowing the exact names. Just know like which one to use when you want to accomplish different things, and know that you can also use the one that they don't have, which is right, left, root. So that is also used sometimes. Yeah, it's going to be all for this video. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.